my name is Iris Argayola, a blessed 3A student.
Chapter 6. Experimental research. In your own words, what is experiment?
In its simplest form, an experiment is simply the test of a hypothesis. The experiment is the foundation of the scientific method, which is a systematic means of exploring the world around you.
What is research?
Research is defined as the creation of new knowledge and/or the use of existing knowledge in a new and creative way so as to generate new concepts, methodologies, and understandings.
Experimental research. So in some ways, experimental research is the most rigorous of all research methods and is arguably the best method for testing cause and effect relationships. Causality. Simply stated, causality suggests that a single event, the cause, always leads to another single event, the effect. Anderson states, causes and consequences concentrate on the relationships between phenomena. How one phenomenon affects another. The conditions for causality. In attempting to confirm causality in a relationship, one must consider the so-called conditions or factors that may exist. A necessary condition is one that must occur if the phenomenon of which it is a cause is to occur. That is to say, if X, the independent variable, is a necessary condition of Y, the dependent variable Y will never occur unless X occurs. Sufficient condition.
A sufficient condition is one that is always followed by the phenomenon which it causes. In other words, if X is a sufficient condition of Y, then whenever X occurs, Y will always occur.
Contributory condition. One type of condition that can be considered, in addition to necessary and sufficient conditions, is the contributory condition.
Contributory conditions increase the probability that a certain phenomenon will occur, but they do not make it certain.
Basis for inferring causal relationships.
Concomitant variation.
Evidence of concomitant variation, or covariation when there are two variables. It indicates that the independent variable X and the dependent variable or assumed effect Y are associated in the way predicted by the causal hypothesis. A second basis for inferring a causal relationship between two variables relates to the time order of occurrence of the variables. To establish the necessary time order requires evidence that the dependent variable did not occur before the independent variable. The third basis for inferring a causal relationship is non-spuriousness or evidence ruling out other factors.
Non-spuriousness or evidence ruling out other factors.
Such evidence merely helps to provide a reasonable foundation for inferring that X is or is not a cause of Y. Controlling the variables. There are two types of variable: the independent variable, the dependent variable.
The independent variable is the experimental variable. It also is referred to as the cause or causal variable and the predictor variable. It is the variable that the researcher manipulates, while the dependent variable is often known as the effect, the subject variable, or the criterion variable. It is caused, or at least affected, by the independent variable.
There are three major techniques for controlling the influence of extraneous variables, two of which are intended to equate the experimental and comparison groups prior to the experiment. One technique involves holding the other variables constant by matching or selecting subjects with the same traits for the experimental and comparison. Another one, which is quite similar on all characteristics or variables that are relevant or capable of affecting the dependent variable, selected for the comparison group. The third and best technique for equating two or more groups before the experimental treatment begins is referred to as random assignment or randomization, not to be confused with random sampling or selection. Internal validity. What is internal validity?
Internal validity refers to the possibility that the conclusions drawn from experimental results may not accurately reflect what went on in the experiment itself.
Traits of internal validity.
History, maturation, testing, instrumentation, statistical regression, biases in differential selection of subjects for the comparison groups, experimental mortality, interaction of selection and other sources of invalidity.
Before taking up specific types of experimental designs, external validity, the second type of validity important to successful experimental research, will be considered external validity. External validity is important because it relates to the possibility that conclusions drawn from experimental results may not be generalizable to the real world. Hoyle, Harris, and Judd define external validity as the extent to which one can generalize the results of the research to the populations and settings of interest in the hypothesis. Threats to external validity. 1. The reactive or interactive effect of
This
testing.
occurs when a pretest increases or decreases the subject's sensitivity or responsiveness to the experimental variable.
2. The interaction effects of selection biases and the experimental variable. This threat is similar to the sixth listed threat to internal validity.
It simply means that one must be careful not to select experimental subjects who are likely to be more receptive to the experimental variable than is the general population.
3. The reactive effects of the experimental arrangements can prevent the researcher from being able to generalize about the effect of the experimental variable on persons exposed to it in non-experimental settings. 4. Multiple treatment interference may occur whenever more than one experimental treatment
It is applied to the same subjects basically because the effects of prior treatments do not entirely disappear.
Experimental designs. Types of experimental research design. True experimental design. 1. The pretest post-test control group design. 2. The Solomon 4 group design. 3. The post-test only control group design. 4. Factorial designs.
The pretest post-test control group design, one of the classic, true experimental designs, is usually referred to as the pretest post-test control group design. The Solomon 4 group design, a second standard, true experimental design, is referred to as the Solomon 4 group design. The post-test only control group design. The post-test only control group design diagrams the same as the last two groups of the Solomon 4 group design. Factorial designs can deal with two or more independent variables and one dependent variable.
Difficulties to be avoided. In order to design an experiment that will be as reliable and valid as possible, the researcher should attempt to avoid the following. 1. Relying too heavily on a single experiment. 2. Using poorly designed or faulty data collection instruments. 3. Not identifying all of the variables that may affect the results. 4. Not choosing subjects that are as representative of the population as possible. 5. Introducing experimenter bias. 6. Introducing making the subjects aware of the hypothesis being tested through unconscious signaling or behavior. 8. Using an insufficient number of subjects. Evaluating the experiment. In evaluating the design and results of an experiment, there are several points that the researcher should consider. 1. The experiment should have the ability to test a null hypothesis, which suggests that there is no relationship between the variables being studied. 2. The experiment should be sensitive. That is, its hold be able to detect relatively small effects or differences. Pre-experimental designs. A few examples of pre-experimental designs follow. 1. The one-shot case study. The one-shot case study, which can be diagrammed simply as XO, is an extremely weak design. 2. The one-group pretest post-test design. The one-group pretest post-test design presents a slight improvement over the one-shot case study. 3. The static group comparison. Another pre-experimental design. which improves a bit more on the preceding designs, known as the static group comparison. Quasi-experimental design.
Quasi is a type of experimental design which represents an improvement over pre-experimental designs, including those just considered, is the quasi-experimental design.
Examples of quasi-experimental designs. 1. The time series design. The time series design is an example of a single-group quasi-experimental design. It takes this form. 2. The equivalent time samples design. ASICON single group quasi-experimental. The equivalent time samples die. It takes this form X10X00X10X0. The pretest postest non-equivalent control group design. This multiple group design has some of the features of the static group comparison and the one group pretest postest design. 4. The multiple time series design. A second multiple group quasi-experimental design is the multiple time series design. Ex post facto designs.
Ex post facto designs represent a weaker type of quasi-experimental design. They are designed to simulate real experimentation by using a static group type comparison such as XOO.
Web-based experiments.
Web-based or internet-based experiments are becoming more common, especially in some of the social sciences. This technique allows researchers to collect large amounts of data from widely dispersed people and locations at minimal cost.
Summary. Reference.
Thank you.